Artificial intelligence can feel almost weightless. You type a question, and seconds later an answer appears. It feels like software somewhere in the cloud. But physical machines did the work. AI models are trained and run in data centers packed with processors, memory, networking equipment, electrical systems, and cooling infrastructure. And the processors are only part of the physical story.
Exactly. The cloud gets a lot less cloud-like once you start listing networking and cooling systems.
Excellent branding, though.
Oh, absolutely. Data has to move. Heat has to be carried away. Equipment has to stay cool and run reliably. That little text box depends on an entire physical facility.
Multiply that infrastructure, and AI growth becomes tied to something much less abstract than software: electricity.
Here's the strange part. AI can become more efficient and still use more electricity overall.
Because efficiency is only one side of the equation. Hardware and software improvements are reducing the energy required for many individual AI tasks.
So, better efficiency doesn't automatically mean lower total demand?
Right. People are using AI more often. Companies are installing far more computing capacity, and applications such as reasoning, agents, and video generation can require much more computation. Put all of that together, and electricity demand from AI-focused data centers is rising quickly. And then the bottleneck can move outside the computer. A large data center concentrates enormous electrical demand in one place. So the question is not simply whether enough electricity exists somewhere. It is whether the local grid, transformers, generation, cooling systems, and transmission infrastructure can expand fast enough where that computing capacity is built. Which means the limits on AI growth do not necessarily live inside the AI model itself.
And that is the larger shift in perspective. We encounter AI as something digital, almost intangible. But at its current scale, its foundations are increasingly physical.